Here I am going to explain the implementation of logistic regression. Logistic regression is a machine learning algorithm used for binary classification problem. It models the relationship between the input feature and the probability of a binary outcome using a logistic function. Now in this video I am going to show a example of implementation of logistic regression. First I importing all the packages. Here I using pandas as PD and numpy package as a NP. Now df I read the data set and stores in df variable. Here I already import the variable, just copy the path and paste in this place. By run this code, first run the packages and then run the second code. Here the data are successfully assessed. Here using get function to know the first 5 rows of our data set. By running this code, here is the first 5 rows of our data set, and using shape it gives the rows and columns of our data set. Now I using the tail function to know the last 5 rows of our data set. Here is the last 5 rows of our data set. Now using describing function to know the calculate the various statistical measures in the data set. And then df is null function. This command calculate the proportion of missing value in each column of the data frame df, and length function to obtain the proportion of missing values of each column. Now I run this code. Here is the output for this. Now using df is null dot sum function is used to calculate the total number of missing values in each column. Here is the output. Here I using the drop now function to drop the null values. Now we see the correlation matrix. Import the package matplotlib as pyplot as plt for visualizing the heat map. Import seaborn as SNS. Here we using the correlation function compute the correlation matrix of the data frame df. The correlation function calculate the pairwise correlation between column of the data frame. Correlation matrix using correlation function here, and then SNS heat map creates a heat map in the seaborn library to visualize the correlation matrix. Coolworm parameter set the color map of the heat map, and true parameter displays the correlation values on the heat map. Dot 1f parameter specify the format of the correlation value, 1 decimal place. Dot 1f plt dot show function is used to display the heat map plot. Plt dot show function used to display the heat map plot. Now I run this code. Here is the heat map for correlation matrix. Now separate the target variable from the future. Now we separate the each of h's from x and y. First we import the standard scalar function. Standard scalar function create an instance of the standard scalar class which will be used to scale the feature. And then now we go to train, test and split the data set. So that here I import this package train, test and split from sklan. This is a logistic regression. Here I import the logistic regression from sklearn.linear model and then from sklearn.metrics import the accuracy score. I run this code. Now we see the split the dataset into train and test data. First, separate the features, target variable features, x and y. Create a new data frame X and create a new series Y by assigning the column 10 years HD from data frame to it. This assigns the target variable values to Y. Now I run this code. The successful X and Y are imported. Here we train and test this code using X train, X test, Y train, Y train, Y test. This command splits the feature X and the target variable Y into training and testing set. The test size parameter specifies the proportion of the data should be allocated for testing. The random state parameter sets a seed value. Now I run this code. Our data sets are completely train and test by running this code. Here scale the feature using standard scalar. Standard scalar class which will be used to scale the feature, and apply the fit transform method to the scalar object to training the test for X train, and transform method the scalar object to the testing set X test. This step uses the mean and standard deviation calculated from the training set to standardize the feature in the testing set. The result stored in X test scaled, which contain the scaled feature of the testing set. Now I run this code. Now we see the implementation of logistic regression model. Build the logistic regression model here. Creates an instance of the logistic regression class which represents the logistic regression model in LR, and then fit the logistic regression model to the training data. The fit method is called on the LR object. Logistic regression is fitted successfully. Now here make the prediction on the test set. Y prediction using prediction function here. And evaluate the accuracy score of the model using the accuracy score function from sklearn to compare the true label with the predicted label. This function the accuracy by calculating the fraction of correctly classified samples. Now I run Y prediction, and here I print the Y predictions. This is the predicted values, and accuracy score is 85. This is our example for implementing the logistic regression. Here we correlation matrix and splitting the data train and test, and here the implementation of logistic regression. And here is the accuracy code. Thank you.